Okay, so in this video, I'm going to take you through two examples involving traditional states examples. So it's a little more classical example in apportionment using the Hamilton method. And then I'm going to give you another example that's a little bit more of a shift away from the typical states and kind of looking at how we can apply the Hamilton method to different items and different objects. In this first example, we're looking at a theoretical Hamilton method example with some fake states, states A, B, C, and D, and their populations are here. And we're going to pretend like there are 71 representatives. So we have our total number of representatives given to us, and we have the state populations handed to us as well. So our process is, first we're going to find our divisor, which we need our total population. So we're going to add up our populations. So 1,050 plus 2,040 plus 3,060 plus 4,050 is going to give us a total of, I see, 10,200. Okay, so we have our total population. We're going to find our divisor, which is going to be our total population that we just calculated, 10,200 divided by the number of representatives we were giving out, which was 71. And this is going to give us kind of a funky 143.662. Again, kind of go through, type that stuff into your calculator. Cool, right? We have our standard divisor, which an interpretation of this means that about every 143 people will sort of earn you a representative at the table. Okay, we'll now go through and find our quotas and lower quotas for each of these states here. So we'll do first state A. We're going to take the population of state A, 1,050, divided by 143.662, which is going to give me 7.308. So again, just kind of writing out my three decimals here. State B is 2040 divided by, again, my divisor, 143.662. And that's going to give me 14.200. State C is my 3,060 divided by 14.662. That's 21.30. And finally, state D is 4050 divided by 143.662. And we'll divide that out and get 28.191. So these become our quotas, okay? And then our lower quotas, we're going to grab the whole number parts, 7, 14, 21, 28. So in this case, we know that everybody's going to get at least these amounts, right? These are the whole representatives. These are the whole human beings that are definitely going to represent these states. Let's see how close we were to the total number of representatives we were trying to give out. And we'll do that by adding up our lower quotas. And we'll get, that's going to end up being 70. So we had 71 that we were trying to give out, but we only have 70 that we actually gave out. This means there is an extra to give out. Okay, now according to the Hamilton method, who gets the extra? It's the person whose decimal values, decimals, 3 places, has the highest value. So think of it like reading 3-digit numbers, right? 308, 200, 300, 191. So as I read off these decimal values, 308 is my largest decimal value. So it turns out that state A gets the extra representative. And we might be thinking, well, geez, state A was the smallest state. Why does it deserve an extra one? Well, it happens to be that it's because of that pseudo rounding kind of thing. It had a little bit more of a resource that got it closer to another representative than the rest of the group had, getting themselves closer to another representative. So this gives us a final allocation of, state A will actually have 8 representatives. State B will have 14. State C will have 21. State D will have 28. Okay. So the apportionment of these states is 8, 14, 21, 28. These are the number of people that will represent them in the House of Representatives in this sort of fake example that we have. Let's take a look at another one. So here's our next example. It's another kind of fake example that I made up, but we're going to pretend like we're now apportioning, again, allocating security officers to different campus locations. These are our centers here in Los Rios, okay? And it makes sense to sort of allocate those officers based off of the population of the students that attend each of those spaces, okay? Normally what I would do in the past is I would tell you, hey, try it. So since this is a video, what you can do now is pause the video, give it a shot. I'll actually go through and write up the solutions real quick here. And after you unpause it, I'll go over the answers. So go ahead and pause the video. Okay, so hopefully you did at least maybe half the problem so far, because you're unpausing the video and seeing what I'm doing here. I added up my populations, right? My total number of students, found my divisor by dividing by the number of representatives, in this case, the number of security guards that we're apportioning. And then I can find my quotas and lower quotas for each of these centers by dividing their populations by the divisor. And one thing I want to notice here is that in this example, we had a total of 38 lower quota sort of apportionments happening here, right? We've given out 38 of these officers, but that means that we are too short of the 40 that we originally had to give out, right? So in this case, we're short by 2 from the 40, okay? So being short by 2 means we have to figure out who's going to get the extra, right? And before, when we had to find out who got the extra, we looked at the decimal values. So we looked first for who has the highest decimal value out of these 3. 685, 659, 655. 685 is the first highest value, so that's the first extra. Oops, goes to Natomas. But we had 2 extras. We're not going to give Natomas another one because we're not supposed to give anything more than 1 extra to any one state or department, or in this case, center. So we'll next go to Elk Grove, which has the 659, which is higher than the 655. So here, Elk Grove is going to get the second extra. Okay. So this is kind of how this works, is that once you give out one of, if you have more than 1 extra, you give the extra to the first highest, then you go down the list to the next highest. So now our extras have been given out, and our answer is going to be that El Dorado is going to get 3 officers. Elk Grove is going to get 11 officers, 1 extra. And Natomas is going to get 26 of our officers. Okay, so now that you've kind of seen a couple of examples, I want you to try out the skills assignment, and I'll provide actually another video after the skills to kind of help you through the skills assignment as well. So